Let us discuss about the part 2 of statistics, which is the probability distributions. When we work about Monte Carlo simulation technique when using crystal ball or any software, we need to define about the phenomena well presented probability distribution. So now we go through different probability distribution, define between the difference between them, when we can use it, what is the most appropriate, best fit for purpose probability distribution that match with our phenomena. All the data in this session collected from different textbook discussing about the probability distributions. As we mentioned, crystal ball or Monte Carlo simulation technique as a simulation technique can be used for anything. When you make investment in real estate, make investment in oil and gas, make some economic study or risk assessment for time, cost for the project, for any risk assessment or need to calculate about the probability can be used through Monte Carlo simulation technique. So the probability distribution can be represent any phenomenon. So you need to select the distribution which match with your project or your assignments that you are doing. So now let us start about the probability distribution. The first one, which is most traditional, which is the normal distributions. Really, normal distribution present many things. For example, here about the people height. Decision making can be used normal distribution. Inflation rate, uncertainty for variables. Future price of gasoline, for example, describes the error in measurement. If you have some measurement error, can be represented by normal distribution, and also manufacturer products can be represented porosity, water saturations, and some economic data. And also we use it in case of make some our result or our result on our university about the degree, how many person it will be, success, excellent, fair, or good, and so on. Always usual normal distributions. Here is the shape of normal distribution. This is the window from the crystal ball. It will be defined. Okay, I already defined this normal distribution. Then I need to define about the standard deviations and the mean. So what I need to define already, it will be normal distribution. Okay, so I need to define a mean and the standard deviation as we discussed this parameter for the last sessions about the statistics. Log normal distribution. Distribution is widely used in situations where values are positively skewed, because most of the value occur near the minimum value. For example, in real estate prices, because it will be positive, no negative, can become a negative, cannot become a negative, and also can be used reservoir characteristic like size, permeability, formation thickness, recovery, economic forces, well cost, completion time, and so on. I will contact us. I will give you this sheet because it can be handy if you forget about it. You define what about the best probability distribution can be used and so on for this. This is the log normal distribution. Already it will be defined by mean and defined by the standard deviations. Triangle distribution. It represents a variable. It represents the uncertainty. Really, it can be used in case for three parameters: minimum, maximum, and most likely. Here mention about it can be used in case, for example, describe number of cars sold per week. Okay, sales. We use it also in when we make about the time itself. We have minimum, maximum, and most likely. Most likely, which is the mode as you mentioned. So we can define, and also for the cost itself. Can define about estimation of the cost, what about the minimum cost, maximum cost, and the most likely, and so on. So it's used in case of uncertainty. In case of variable, we use a different normal distribution, log normal distribution, and the other distribution. So the triangle distribution is used in case of the time, can be used in case of the time, and sometimes we use normal beta distribution for some textbook. for the time itself, but on the cost it can be used for the triangle distribution in case of the cost, because you have the price or cost, have the minimum, most likely, and the maximum. Here mentioned for some textbook can be used for the car sold, how many cars sold per weeks. Also has 3 parameter, minimum number, maximum, and most likely. Here we mention about the likest, the maximum, and the minimum. This data should be defined in the triangular distributions. Binomial distribution. It can be used for many things, but here are defined geological risk, the most commonly used, evaluating reliability of the equipment, to trade off the cost of excess equipment if you need to define about how many equipment exactly I need, power generation facilities on offshore platform or remote location, injection pump and pipelines, and so on can be tried. It will be for each trial only 2 outcomes. The trial are impedance. What happened in the first trial does not affect the second trial, and so on. So if you have a make a trial for one, it not affect the another one. Remain for the same from the trial. The probability of an event occurring, it will be the same from one trial to another. This is the phenomena for the binomial distribution. Should be understand before use it, because it can be make some bad outcome if we use a wrong distributions. Here is the shape. Here we have the bar like this. It's called a mass distribution function. Okay, here or this one, which is like the normal distributions, the density function. Okay, so it for the tallest of the building, maybe one tallest of the or heights of the people, maybe one height of the people can be 1.53 meters. Okay, but in case of running a coin or something, it will be king or head, cannot be, so it will be one outcomes on numbers. Like the horn itself, when you're running, it will be from 1, 2, 3, 4 until 6, should be one outcomes, cannot be a fractions. Okay, so this is the problem, the difference between binomial distribution. It will be mass bar and density function, as we mentioned before. Here's the probability of occurrence, and the number of trials should be occurred here. Have this example, it will be very nice. In case of toss of fair coin, probability of occurrence, it will be 0.5. What is the probability of getting exactly 2 heads if I make 6 tosses? So apply these equations. So what's the probability of getting 2 heads? So I apply this equation: 6, 2, 4, 6 minus 2, 0.5 is 2, here it will be 0.5 is power 6 minus 2, this is 0.234, the probability of occurrence 2 head in 6 tosses. Another example, if you make drilling a well, what about the chance to obtain 20 successful wells? In case of 25 well drilling program, if the probability of success, it will be 0.8. So I have program 25 well. What is the probability that I have 20 successful well? So in this case, about this is the total well, the total experimentals. Here is the successful that I have. The value here is the successful for the number, power number of the successful well. Here's the total well minus the successful well. 1 minus this probability of successful 1 well 0.8, here 1 minus 0.8. So the probability that I have 20 successful well, it will be 0.195. Poisson distribution describes the number of times an event occurs in a given interval, and it can be used in case of simulation of the number of the phone call per minute or the number of error per page, and so on. So if we have the model of simulation of communications or the phone or capacity of the networking and something like this, define about that about the number of the phone call per minute. In case of you making car for fueling itself, how machine of fueling you need? You need 2, 3 or 4, because if I have an extra one, it will be money without gain. But if I have small number, it will be a crowded of car, so I cannot accommodate our business. So should be apply the model for Poisson distributions. The same as Poisson distribution, it will be the rate. It will be applied just a rate that will be applied here. The exponential distribution is inverse of the Poisson distribution. The exponential distribution is widely used to describe events recurring at random in time, such as the time between failure of electronic equipment. A Poisson distribution which describes the number of times an event occurs in a given interval. So it will be a relation between them. An important characteristic of the exponential distribution is the memoryless property. In other words, time has no effect on future outcomes. So what happened can be happened or not does not affect the time between each others. Here according to the rate also, but here about the Poisson distribution, about the time itself, and it can be described. Really, it can be, as I mentioned, if it has the traffic time between the car, about the traffic, and so on, can be used according to the design of the traffic for the villages, and so on. If you need about probabilistic analysis, can be used also exponential distributions. Geometric distribution describes the number of trials until the first successful occurrence, such as the number of time you need to spin a roulette wheel before you win. So come time you need to make a spread roulette until you success. The number of trials is not fixed. You have a lot of number of trials that you need to be done. The trial continue until the first successful. Is the same from trial to trial. The opportunity will be the same, but it will be a discrete. Okay, here probability of occurrence, and apply about this, about the geometric distributions. Hypergeometric distribution, the binomial distribution trial are independent, while the hypergeometric distribution trial changes the probability for each subsequent trial and whole trial without replacing. We have an example. If you have a box of manufactured part and you know that you have some defective part, find it is defective and remove the part from the box. If you choose another part from the box, the probability that it can be defective is most lower than the first part, and so on. So every effect trial event affects the second trial. The total number of each item or elements, the population size is fixed number. The number of the sample size, the number of trials represent a portion of the population. Initial probability of success in the population changes slightly after each trial. You have a change of successful itself. Also, it will be a discrete. Here is number of the trial, probability of occurrence, and the probability. Weibull distributions, or called Rayleigh distribution. Describe, it will be fatigue test if you have the fatigue, reliability study. It can be used in effect of the wind, can be by Rayleigh distributions, wind speed, as you can mention here, and manufacturer might find the effect useful in describing part failure during burn-in periods. Useful analyze noise problem, can be used also in communication system, and also many phenomena can be used with Weibull distributions. He mentioned it is not. Here we have defined by it's called three factor: location factor, scale, and shape. But here, if you have, for example, the normal distribution, you have the value of the standard deviation and the average, he converted direct to the Weibull distribution by this factor, because there is a relation between this factor and the arithmetic mean or the average and the standard deviation, and so on. So we have some equation to calculate direct, or you can just input as a normal distribution, and when converted to another one, he already converted direct by the crystal ball software. Do it direct. Beta distribution is very flexible, commonly used to present the variability of over fixed range. It can be used in conjunction with Bernoulli distribution. Application can be used, presents uncertainty in the probability of occurrence of an event to describe empirical data and predict the random behavior of percentage and fractions. And it represents something, for example, beta distribution. If we have a steel bar, about the diameter of the steel bar can be presented by the beta distribution. If we have a thickness of the pipe itself, it can be presented, this thickness manufacturer can be presented for some textbook by beta distributions. Here is the beta distribution presented by the scale factors beta and alpha. This is the parameter can represent about the beta distribution. Gamma distribution, it represents a physical quantity like pollution concentrations, and also it was measures the time between occurrence of event, can be used also. Inventory control, economic theory, and insurance risk, because you have a time of occurrence of the events with the insurance, so insurance can be applied by the gamma distribution. And also it improves corresponding estimation of the gas stream of BVT, pressure volume temperature matching the prediction. True for volatile oil and gas condense or reservoir, and the black oil simulation with high percentage of heavier hydrocarbon. So use it also in BVT, can be presented by gamma distributions. In the density function, it will be location, scale, and shape also should be defined. Logistic distribution is commonly used to describe growth. The size of population expressed as a function of time variables. It can also be used to describe chemical reaction and the course of the growth of population or individual. It is used in some very important in industry. If I need to, what about expectation of the growth of the people after 1 year, 2 years, 5 years, 10 years, 20 years, and so on. It will be a factor really when you make economic study, because effect of the increase of the people, increase of the demand of the oil, demand of the gas, and demand of your product. So population, it will be an effective factor in your model, should be presented by logistic distribution. Pareto distribution, it will be used investigation associated with such empirical phenomena as the city population size, also city population, occurrence of natural resources like the size of the companies, personal income, stock price, fluctuations, and the error clustering in communication circuits. So many different can be used about Pareto distribution. So you can see the Pareto can many different aspects for many different projects can be used Pareto distribution. So every distribution can be used different, but you need to have, this is all from textbook, so can be used direct. In case of communication circuit, use a Pareto distribution direct. But if you have some phenomena don't know, you need to make this analysis about search, what about the parameter that presented your, what about the Pareto distributions presented your case. This is the shape of the Pareto distribution, also location and the shape factor defined by 2 parameters only for Pareto distributions. Extreme value distribution, known as jumble distribution, is commonly used to describe the large value of the response over the time, like flood flow, rain flow, earthquake. In case of high live load, we use it, extreme high live load, we use it also in the analysis. Breaking strength of the material, construction design, aircraft load, and the tolerance, we use the extreme value distribution, which is the extreme value distribution can be applied. We have the mode shape and the scale shape, which, as I mentioned before, it will be a function for the standard deviations and the average or the arithmetic mean. Here in the crystal ball, with crystal ball, you can use the custom distribution to present a unique situation that cannot be described using other distribution, so it can be custom. So you make the distribution by yourself by combination between rectangle. If you need some case, some specific case, you need to be defined. Called the custom distribution. It will be during the like this. He have a base range. Maybe also we have a uniform distribution if the probability of occurrence it will be the same or custom like this. If you don't have a distribution and you have a data, so if you have the data, we have the curve that we mentioned. Okay, from the data as we discussed from statistics from the first the previous sections. So we have this data draw. So we apply chi-square or Kolmogorov-Dimitrov test. To apply we have the data. We have already the data presented by the figures as you mentioned. Then he apply different value. For example, about the normal distributions, log normal distributions, Pareto chart, and so on, and calculate for MD1 the chi-square. From this, he define what about the best probability distribution which best fit for your data that you have. So if I have the data, he makes the analysis and he make apply what about the best distribution match with your data that you make from the test. We have two tests here. Chi-square Kolmogorov-Semenov test, it will be the same. He apply it direct through these equations for the software and provide you the best or the number one match with your phenomena that will be applied. For example, if we found that number one is binomial distribution, but my phenomena have fractions, so cannot be binomial because it will be a district, it will be a mass, not a density. So in this case, I go to the second one in the ranking. Okay, and so on. So I need to understand the probability phenomena itself and make this test and select the best suitable probability distribution for my data to be in the Monte Carlo simulation technique that we have. Okay, if you have any data or you need any question or an inquiry, let me know and discuss about it. And if you contact me about if you need this data, a hard copy, contact me to send it to you. Okay, thanks a lot, and let us go to direct to the Monte Carlo simulation by using crystal ball.